How do you know whether a sudden increase in defects is a real problem or just a normal variation in the process? In this video, we're going to explore control charts, one of the most useful quality management tools for monitoring process performance over time. We'll discuss how control charts help project managers distinguish between normal variation and unusual variation, and how to recognize warning signs that a process may be changing. Every process has variation. Even when a process is performing normally, the results are rarely identical every single time. For example, imagine a software team tracking the number of defects discovered during each sprint. One sprint finds 18 defects. The next sprint finds 20. The following sprint finds 17. Do these differences indicate a problem? Not necessarily. Some variation is expected. The challenge is determining whether the variation you're seeing is simply normal process behavior or evidence that something unusual has occurred. This is exactly what a control chart helps you determine. A control chart helps answer a simple question: is this process behaving normally? If the variation is normal, the project manager should continue monitoring. If the variation is unusual, the project manager should investigate further. One of the biggest mistakes organizations make is overreacting to normal variation. Another common mistake is ignoring signals that indicate a real process problem. Control charts help avoid both mistakes. A control chart plots process performance over time. The chart typically contains three important lines: the center line, the upper control limit, UCL, and the lower control limit, LCL. Each data point represents an observation collected from the process. In our example, each point represents the number of defects discovered during a sprint. As new data is collected, additional points are added to the chart. The goal is not simply to look at individual data points. The goal is to determine whether the overall process appears stable and predictable. Let's start with the center line. The center line represents the average performance of the process. Suppose our software team historically finds an average of 15 defects per sprint. The center line would be positioned around 15 defects. This does not mean every sprint will have exactly 15 defects. Some may have 13, others may have 17. The center line simply represents the process's normal operating level. It provides a reference point for understanding how the process typically performs. Now let's discuss the upper control limit and lower control limit. These limits define the expected range of normal variation. Suppose the control limits for our process are: upper control limit equals 20 defects, lower control limit equals 10 defects. If the process is stable, most observations should fall within those boundaries. The upper control limit represents the highest level of variation still considered normal. The lower control limit represents the lowest level of variation still considered normal. Together, these limits define what we would expect to see if the process is behaving consistently. Control limits are based on actual process performance. They help determine whether the process is stable. Now let's talk about the first type of variation. This is called common cause variation. Common cause variation is the natural variation that exists within a stable process. Suppose our software team records the following defect counts: 18 defects, 20 defects, 19 defects, 16 defects. All of these values fall within the control limits. There are no unusual patterns, no sudden spikes, no significant shifts. Even though the numbers vary, the process itself appears stable. This is normal process behavior. When common cause variation is present, the correct response is usually to continue monitoring rather than immediately making changes. Many organizations waste time trying to fix processes that are already operating normally. A project manager should avoid reacting to every small fluctuation. Variation alone does not indicate a problem. What matters is whether the variation is expected or unusual. Now let's look at special cause variation. Special cause variation occurs when something outside the normal process affects performance. Unlike common cause variation, special cause variation suggests that the process may no longer be stable. Let's say our software team suddenly discovers 32 defects during a sprint. That result falls well above the upper control limit. This is no longer a normal variation. Something may have changed. Perhaps a new framework was introduced. Perhaps testing procedures changed. Perhaps requirements became more complex. The control chart does not tell us what caused the change. It simply tells us that the variation appears unusual and deserves investigation. This distinction is extremely important. A control chart identifies signals. It does not identify root causes. Once a special cause signal appears, the team may need to perform root cause analysis, conduct a quality review, or investigate process changes. One common misconception is that you only need to pay attention when a point falls outside the control limits. In reality, a process can show warning signs even when every data point remains within the limits. This is why project managers must look at patterns, not just individual observations. For example, imagine the defect counts over 7 sprints look like this: 16, 17, 18, 18, 19, 19, and 20 defects sequentially. Every point is still within the control limits. At first glance, the process may look acceptable because nothing has crossed the upper or lower control limit, but the steady upward trend suggests something may be changing. This is where the rule of 7 becomes important. The rule of 7 means that if 7 consecutive data points show a non-random pattern, such as a steady trend or appearing on the same side of the center line, the process may no longer be stable. This signals that something may have changed and the project manager should investigate. This does not automatically prove the process is defective. It means the pattern is unusual enough that it should not be ignored. Remember this: a point outside the control limits is a warning sign. 7 consecutive points showing a non-random pattern is also a warning sign. Both indicate that the process may need investigation. Another common confusion is the control limits and specification limits. They are not the same thing. Control limits are based on actual process performance. They help answer the question, is the process stable? Specification limits come from customer requirements, product requirements, or quality standards. They answer a different question. Does the output meet requirements? A process can be stable and still produce unacceptable results. Imagine our defect process consistently produces 19 defects every sprint. Those results are extremely consistent and remain within the control limits. The process is stable. However, suppose management has established a quality requirement that no sprint should exceed 10 defects. In that case, the process is stable but still failing to meet expectations. Control limits measure process stability. Specification limits measure conformance to requirements. Another common comparison involves control charts and run charts. Both tools display data over time. A run chart simply shows performance data and trends. A control chart includes everything found in a run chart but adds the center line, upper control limit, and lower control limit. Those additional boundaries help determine whether variation is expected or unusual. A simple way to remember the difference is run chart equals trend over time. Control chart equals trend over time plus control limits. Let's discuss some common PMP exam traps involving control charts. The first trap is assuming that every fluctuation requires corrective action. Not true. If the variation is caused by common causes and the process remains stable, the correct response is usually continued monitoring. The second trap is confusing control limits with specification limits. Remember, control limits evaluate process stability. Specification limits evaluate whether requirements are met. The third trap is assuming a control chart identifies the root cause. It does not. The chart simply signals that something unusual may be happening. Investigation must still occur. The fourth trap is assuming a stable process automatically produces acceptable outputs. A stable process can consistently produce results that fail customer requirements. Always separate process stability from customer acceptance. When using a control chart, the project manager is really trying to answer one simple question: is this process behaving normally? If the variation appears normal, continue monitoring. If the variation appears unusual, investigate and determine why. The goal is to understand the difference between normal variation and meaningful change. And that ability to distinguish between the two is what makes control charts such a valuable quality management tool. If you found this video helpful, please like this video, subscribe to PM Aspirant, and visit pmaspirant.com for more project management resources. Thanks for watching, and I'll see you in the next video.